In this video, we'll talk about the disk method for finding the volumes of solids of revolutions. It's really an easier version of the wash method that will come next. So how does this disk method work? Well, we'll see why it's named that way in a second. But the idea is, let's take the solid of revolution that we have here, the one that's drawn right over here. If I were to take a slice of this vertically and sort of chop down through it, well, what do I get when I make that slice? I get this circle here. This circle, or this disk, is what I get when I take a slice of this object in a certain direction. So like we mentioned in the last video, the idea of how do we find this volume comes down to I want to add up a bunch of little slices where I find the area of each slice. So in this case, each slice is a circle, so it's easy to find the area. Now let's step back to the function point of view. So I want to take this region here in this first picture on the left. I want to take this region and I want to revolve it around the x-axis. And so when I do that, I'm going to trace out the solid revolution you see in those three pictures. And every slice I take vertically gives me a circle. So that's great. Well, if I want to find the total volume, I need to integrate the function that is the area of each slice. So what's the area of each circle? Well, each slice is a circle whose area is going to be pi r squared. But what's the radius here? Well, if we look back at this picture here, the radius that we get right in here is exactly the value of the function. So this is going to be the area as a function of x is pi times f of x squared. And I want to add that up over the range of my function. So again, I'm taking individual slices, I'm stacking them together, adding up the areas of all these different slices to give me the volume of the entire region. So I get that by integrating this a function over the range that I care about. So the volume should be integral from a to b of a of x dx, which is integral of a to b pi times f of x squared dx. And for the disk method, that's what we get for finding the volume of this solid of revolution. Well, let's see an example of what this looks like in an actual problem. Find the volume of the solid obtained by rotating the region under the parabola y equals 6x minus 2x squared between x equals 1 and x equals 3 around the x-axis. So this parabola will be 0 at 0 and 3. So let's draw a picture. It looks something like this, and I care about going between 1 and 3. So 1 and 3. I want to take this region here and revolve it around the x-axis. So I'm going to get some weird cut-off bowl-shaped thing. So here is my slice. That's the radius of my slice. I'm going to rotate that around the axis, so I'm going to get circles with that as my radius. So the volume is going to be the integral between my bounds of 1 and 3, pi times the radius, which in this case is exactly this function value, squared, dx. And now we just work out this integral, expand everything out, and see what we get for an answer. We then integrate to find the antiderivative. Then we just plug in our endpoints and subtract to get that this answer comes out to 128 over 5 pi. So that's the basic process for how you find volumes of solids of revolution when you have the simple case of it's one function around the x-axis and you're given it this in this setup here. There are more complicated versions of this problem that we'll see over the course of this section, but this is the simplest one you can lay out from as a starting point.